Ever wondered why volcanoes, one of nature's most formidable forces, are so unpredictable? These fiery mountains hold an undeniable allure, a paradox of beauty and destruction. They stand majestic in the landscape, yet beneath their calm exterior, a tumultuous power brews. Volcanoes are a testament to our planet's dynamic nature, to the churning, boiling reality beneath our feet. They are the Earth's way of letting off steam, quite literally. But what makes them so unpredictable? Why can they lie dormant for centuries and then suddenly awake with devastating consequences? Recent news has seen whispers of potential eruptions, reminders of the constant game of geological Russian roulette we play. These events rekindle our fascination with these natural phenomena, but also our fear. The unpredictability of volcanoes poses a significant challenge to us, making it difficult to prepare for or anticipate their eruptions. To understand why volcanoes are so unpredictable, we need to delve into the science behind volcanic eruptions. Volcanic eruptions are not random events, but result from a complex interplay of geological forces beneath the Earth's surface. Despite their dramatic and often unexpected appearances, volcanoes are a direct result of the Earth's internal workings. Underneath our feet, the Earth's crust is divided into several large plates. These plates are in constant motion, and when they collide or move apart, magma from the Earth's mantle can rise to the surface. This is due to changes in pressure. When the pressure is high, magma remains beneath the surface, but when pressure decreases, magma rises and can break through the Earth's crust, resulting in a volcanic eruption. Now, imagine this magma as a fizzy drink. You know how you get bubbles when you open a soda can? That's because of a sudden drop in pressure. The same thing happens in magma. This magma contains dissolved gases, and as it rises and pressure decreases, these gases form bubbles. The rapid expansion of these gas bubbles can cause the magma to explode out of the volcano, much like the fizz bursting out of your shaken soda can. But not all eruptions are explosive. The type of eruption largely depends on the magma's viscosity, or its resistance to flow. Think about the difference between pouring honey and water. Honey is more viscous and flows slowly, while water is less viscous and flows quickly. In the case of volcanoes, low-viscosity magma leads to effusive eruptions, where lava flows out slowly and steadily. On the other hand, high-viscosity magma can lead to explosive eruptions, where the magma is blasted into the air along with ash and gas. These explosive eruptions can be incredibly powerful and devastating, as the eruption of Mount St. Helens in 1980 demonstrated. So, while it may seem like volcanoes erupt out of nowhere, there's a whole lot of science going on beneath the surface. But even with our understanding of these processes, predicting exactly when and where a volcano will erupt remains a daunting task. With this understanding, we can begin to appreciate why predicting these natural disasters remains a significant challenge. Despite understanding the science behind eruptions, predicting exactly when a volcano will erupt remains a monumental task. Volcanoes are inherently unpredictable, keeping their secrets buried deep within the Earth's crust. The challenge lies not just in the complexity of these geological behemoths, but also in the sheer diversity of signals they emit before erupting. Seismic activity, for instance, often precedes an eruption, but the timing and magnitude can vary greatly. Gas emissions, too, are a critical sign. Changes in the volume and composition of gases like carbon dioxide and sulfur dioxide can indicate a magma movement. However, different volcanoes emit different gases, and the same volcano can emit different gases at different times, adding to the complexity. Then, there's ground deformation. As magma rises to the surface, the ground above it swells, creating distinctive patterns. Yet these patterns are as unique as fingerprints, and interpreting them accurately requires continuous monitoring and a deep understanding of each volcano's history and behavior. So, you see, predicting eruptions is a bit like putting together a giant jigsaw puzzle, with each piece representing a different signal from the volcano. While we may not be able to predict every eruption, advances in science are continually improving our ability to mitigate the risks. So, what have we learned about the enigma of volcanoes? Volcanoes, with their fiery majesty and destructive capabilities, are an embodiment of nature's unpredictable power. We've delved into the science behind eruptions, exploring how subterranean pressures and the movement of the Earth's crust can lead to these awe-inspiring events. From the gradual buildup of magma to the explosive release of energy, every eruption tells a unique story of geological processes. Yet, the enigma extends beyond the spectacle. The challenge lies in predicting eruptions, a task as intricate as deciphering an ancient code. Despite the strides in seismic technology and geological understanding, volcanoes retain an element of surprise, often catching us off guard with their timing and intensity. In the face of such formidable forces, complacency is not an option. Continuous research and monitoring are vital, as exemplified by the ongoing situation at Iceland's Fagradalsfjall volcano. The power and unpredictability of volcanoes remind us of the dynamic and ever-changing nature of our planet. As we continue to study these formidable forces, we hope to better predict and prepare for their eruptions.